In this short video, we're going to be looking at the acceleration due to gravity. So in my last video, I stated that the acceleration due to gravity is only acting in the vertical component of the velocity. So therefore, the horizontal component, if we neglect air resistance, remains constant throughout his motion. So therefore, the only acceleration and only change of velocity that we see in projectile motion in two dimensions is in the vertical dimension. So, if I drop a ball, we'll see that there's an acceleration acting on this ball, and it goes from a velocity of 0 initially in the vertical direction to its maximum when it reaches the ground. Now we can calculate this, but in this case we're not going to. Now if I compare that motion that we just saw there to the motion of an object that has a horizontal velocity as well. So we see that the vertical motion of both the object that has a horizontal motion as well and the one that's stationary in the horizontal dimension both have the same acceleration due to gravity acting on them. They're both the same ball, so they have the same mass. So what we see is that the motion of a free-falling object in the vertical direction is exactly the same if we only look at the vertical dimension of our object that has horizontal and vertical motion. So the key points from this video: a vertically free-falling object with no horizontal velocity has the same acceleration acting on it as an object that has a horizontal motion and a vertical motion. So we can compare the motion of a vertically free-falling object to that of a vertical motion of a two-dimensional moving object.